groups and to register. All right. Now we're going to begin a medley of presentations of said working groups. The first of which will be by Jan Nasinovich, data scientist at Slate AI. His working group will focus on streamflow prediction in Canadian prairies. With that, Jan Nasinovich.
Hi, folks. Can you hear me okay?
Yes.
So I won't take up too much of your time. This is nice and short. I know we're heading a bit behind. Sharing my screen. Can you guys see my screen?
Yes.
Awesome. Okay, so slideshow. Okay, so I'm organizing a group on streamflow prediction. Since we're doing this with NRCan, I decided we'd focus on data from the Canadian prairies. So motivation. I know it's kind of hard to keep track of all the different crazy things that are happening in the world, but you know, before the recent news, I don't know if you remember, but last summer there was pretty huge issues with drought in the West. So that kind of is the motivation here. As you know, drought is a shortage of precipitation, causing insufficient water availability in Western Canada. This is a quote from last summer. Western Canada was experiencing frequent and severe droughts, and that can have oops, sorry, didn't mean to scroll there. That can have problematic impacts on the environment, on vegetation and everything, on forest fires. So approximate timeline, we're gonna likely discuss the problem and plan out the project approach for about a week, do some review of time series, find data and do some data exploration. Then we'll create initial models, and then we'll work on tuning them, trying maybe more advanced approaches. And then we'll see if we can deploy the models. This is kind of a flexible timeline. If people need some stuff to happen earlier, some stuff to happen later, that's okay. I'm not going to be a stickler about it. The point is to come up with something cool. So in terms of data sources that we'll use, obviously this is involvement with NRCan, so hopefully we can use some NRCan data as much as possible. But the types of data sources we might use, streamflow gauges, topographic data like elevation and slope, basin data like size and vegetation, rainfall data, temperature data, we can just get that from some API, and soil data. Obviously this is flexible, we could use other things too. As you probably have noted, some of this is time-dependent data and some of this is location-dependent. So part of the challenge will be figuring out how to fit a model that really accurately could predict things for different locations around Western Canada. Or more than that, there's likely Western US data as well that we could include. So possible approaches, from most advanced, more advanced to more simple. We could use time series transformers, time to vec. We could use LSTMs, design our own neural network with that, or we could use a simple approach like the SK forecast package, where use a sklearn model like random forest or like gradient boosting for these predictions. I think in general, we could treat it as kind of like a supervised learning problem or a time series problem or some combination thereof. But we'll all be learning that together. And obviously reading to start doing a lot of reading and learning these things. That is it, I believe. So anybody have any questions, comments, concerns?
Thank you very much for that, Jan. Regarding questions, comments, and concerns, I will ask everyone to put those in the chat for the benefit of time. Regarding how you can register for what Jan just talked about, I will share the link for that in the chat right now. Now, one other detail, I've already mentioned this, but I will take a chance to reiterate. If you feel that what's being discussed, you don't quite have experience in all of that from before, then the first couple of weeks of most working groups will really be focused on getting you up to speed. We can't guarantee that you will be able to get up to speed, but if you're willing to put in the time, chances are that you should be able to.